Hey guys, my name is Karis Park, and today we're going to go over all of the ways to take the antiderivative. So first, to start off, we're going to have U substitution integration. So to use this, the U should be the inside, and its derivative must be in the problem. And here's a side note, you can finagle numbers, but not variables. So let me show you this whole process in two examples right here. So to start off, take the antiderivative of this right here. So the u is going to be the inside, so you let the inside equal that, and then you take the derivative of this, which is going to be du, and then when you take the derivative, you have to put dx at the end, and then you're going to substitute whatever you see. So u is going to be this part, and then du is going to be this end part, but except that there's a 3 right here. So as I said in this side note, we can finagle numbers but not variables. So since 3 is not a variable and it's only a number, we can put 1/3 outside of this. And then we can, as I said, plug in u for 3x plus 1, and then you can take the antiderivative of this, and you will get 1/3 times u to the 5th divided by 5 plus c. And please do not forget the plus c. Moving on to the second one, take the antiderivative of this right here. As I said right here, the u should be the inside and its derivative must be in the problem. So u will be this inside, and it cannot be this one because the derivative of this is 2 and we don't account for this right here. So u is going to be this part, and luckily, as we can tell, du is going to be whatever we have in this problem. So as we did in the problem up there, u will be equal to this part, so we just plug it in for this, and since du, and don't forget the dx when you take the derivative. So the du will be the remainder of the problem, so you can just plug it in right here as this. And then you're going to take the antiderivative as you always do, and you're going to do u10 plus 1, and then 10 plus 1 on the bottom, and you'll get u to the 11 divided by 11. And don't forget the plus c, and you just plug u back in using this, and this is your final answer. So the second way to take antiderivative is Lipet. Lipet stands for logs, inverse trig, polynomials, exponentials, and trig. So again, don't forget the plus c once you get the answer. So the rule for Lipet is this. You have to memorize this. So it's going to be when it's the antiderivative of u times dv, then you're going to get u times v minus, and then you take the antiderivative of v times du. So when we use this, let u equal what comes first in Lipet. So depending on what you have in the problem, you look at these 5 things and you see which one comes first. So this would be first, second, third, fourth, fifth. So if we only have these two, then obviously this would be the u, and then as I stated here, this part will be the rest. So we'll see in this problem right here what I'm talking about. So take the antiderivative of x times e to the x, and then dx. So you can't do u sub in this problem because there is no derivative of any of these two in the problem. And so we would use Lipet because there is an x, which is just a polynomial, and then you would use e to the x because this is an exponential. So since p comes before e, you're going to let p, which is the x, equal u. So as I did here, and then you're going to take the derivative, and then du times, and then the derivative of x is 1 times dx. So basically this is du equals dx. Now, as I stated over here, dv is going to equal the rest. So e to the x times dx was not accounted for, so that is actually the rest. So as I said here, you're going to take the antiderivative because the dv and then dx is over here. So you take the antiderivative and it comes out to be e to the x. So then now we're going to use these two and we're going to use those 4, and we're going to use this and then come up with the antiderivative. So as I said here, it's u and then times v minus, and then take the antiderivative of v times du, and then du is right here, so it's going to be that. So then you just simplify this, and over here we're just going to take the antiderivative once again, but this is doable, so we don't need to use Lipet or u sub or anything because we know the antiderivative of e to the x, which is just e to the x. And don't forget there's a minus sign here, so we're just going to put minus and plus c. Here's the second problem of a Lipet situation. So it's x times sine x times dx. So as I said, this is a polynomial. So in Lipet, the polynomial, So the polynomial is right here, and then sine. So that's a trig. So since this comes first, this is going to be equal to the u, and then dv is going to be equal to the rest. So then, as I said here, we're going to take the derivative, and we get du equals dx, and then we're going to take the antiderivative on this side, and we're going to get v equals negative cosine x. So then again, we're going to be using this formula right here, and just plug everything in, and we will end up with negative x cosine x plus sine x plus c. So the third way to integrate is called tabular integration. So this is used for repeated integration by parts. So it only works if there's a polynomial times trig or polynomial times exponential. Keep in mind there must be a polynomial, and I'll show you why. So here's the next step into the process of this integration. Multiply diagonally to the right bottom. You'll see what I'm talking about, and switch off the signs starting with positive. Then it would be negative, positive, and then etc. depending on where we stop, and I will go over that soon. So stop until u equals 0. So let me show you this in an example. So take the antiderivative of x squared times sine of x and then dx. So as I said, there must be a polynomial, and thankfully we have that here, x squared. And then now we can use this one because there's a trig right here. So u is going to be equal to the polynomial. So in u, you're going to just take the whatever you have in the problem, and then you derive it until you get to 0. When you get to 0, that's when you stop. And then you go to the next side of this, and then you're going to take the other one, which is the trig, and the trig is sine of x, so then we antiderive it because this is dv, and we want to take the antiderivative, and we would get negative cosine x, keep going, and this is where we stop because the u stopped at 0. So then, keep in mind that I stated that there was a sign change every time you go down. So this is positive, and you start off with a positive always, and then negative, positive, negative. And then, as I said, multiply diagonally to the bottom right. So we're going to multiply this way, and so as you can see in the answer right here, I multiplied x squared times negative cosine x, and then I stated that there was a sign change, so it would be negative 2x times that, and then it would be plus 2 times cosine x, which I did here, and don't forget the plus c. So here's another problem. U will be equal to this polynomial, and then e to the x is the exponential. So that's why u dv is going to be e to the x. So first you do the u, you take the derivative until you get to 0, that's where you stop, and then you move to the right side, and then you take the antiderivative of e to the x, which is luckily just e to the x, and then keep in mind that we would have to do the sign change. So the final answer is going to be x times e to the x, and then minus e to the x, and then you're just going to put plus c. And you can't obviously go forward because there's nothing here. So this is actually the last one, integration, actually no, it's not the last one. But integration by partial fractions is when a denominator can be expressed as a product of two linear factors. So as you can see in this problem, we can set this up into two factors. So that's what I did right here. And you just factor this to get these two. And then what we're going to do is let a and b equal the numerators so that we can get each of the denominators to have a common denominator. So it would be this, but except we're going to separate it into two factors. So as you can see what I did in the pink, I would multiply the top and bottom both by whatever is needed to make it into x squared minus x minus 12. So I did that. And then this is what is going to be the overall thing. And then I would let the numerator because the numerator and the problem is 1, that's what the 1 is going to equal, and then it's a times, and then since this needs x plus 3 to make the common denominator the same, that's what I'm going to do here. And on the other side, the same thing, since I need an x minus 4 on this side, I'm just going to multiply it here. And keep in mind, we're only doing the numerator because we already got the denominator to be the same by multiplying these. And then we're going to try to get this part or this part to equal to 0 so that we can solve for one of the a's and one of the b's. So then we're going to let x equal 4. So for this part, we're going to let this whole thing equal 0. So when 4 minus 4, this is 0, and then times b, that's 0. So this whole thing cancels out. So we're left with this, and then we're going to solve for a to b. Oh, and then we would also plug in 4 here, but we would also we would result in a equals 1/7. And then we go to let x equals -3, and then because we want this to be 0, and then we end up with b equals -1/7. So then there's a few more steps after this. This is the original problem, I just rewrote it. So since we came up with what the a and b's are supposed to be, we're actually going to plug it in. So we're going to separate the two by their factors on the denominator, and we're going to plug in what we got for the a's and b's. And since, as you can tell, I did it right here, this is the a and b's, and then we're going to just bring this out because you can bring out numbers, and then you're just keep in mind that there's a negative sign right here. And then we're going to take the antiderivative of this, and this is pretty easy because it's just the ln of absolute value of x minus 4, and the same part over here. And then to combine this to make it more concise, we're going to do ln of, and then to the 7th, 1/7th power. And then we're just going to do this, and since it's minus, we're going to divide it. And then don't forget the plus c. Here's one more problem. So we're going to do the denominator and put it into two separate factors. So these are the steps that I took in order to get these two. And then I just rewrote this part with the two factors. And then I'm going to separate it into a and b. But keep in mind that the numerator is x minus 4. So what I would need to do is keep it like this and then do a and b. But when we do this part, and we're trying to solve for a and b, we still need to make the left side x minus 4. In the other case, we let it equal 1 because the numerator had 1. So we would let x equal 1/2 because in this case, we want this whole thing to equal 0 so that we can solve for, we would let, and then we would solve for b. These two should be switched. But then we would do this side as well, and then we would let this whole thing equal 0 so that we can solve for a. So now, as you can see down here, I rewrote the thing again, and then I let the a come out because it should have been up here, and then I let the b come out. And so here's a side note, don't let a or b be a decimal. Keep it as a fraction. And that's because you can see that if you bring it out, you want to be able to write it like this so that it's more concise. And then you're going to do the antiderivative of this, which is ln of absolute value of x plus 2, and then you would just do this part. But the thing is that this denominator has 2x minus 1. Since there's a 2 in front of the x, that means that when you take the antiderivative, you still need to take out a 1/2. So in order to compensate for that, we're going to take out a 1/2 in advance and multiply the top by 2. This way, this whole thing is the same thing as this whole thing because anyways, these two cancel out. But it just makes sure that you still take the 2x into consideration when you take the antiderivative. So then when you go on to here, you would just make it more concise by multiplying these out and then taking the antiderivative of this. And then please make sure to go check out for questions, and thank you for watching.